Okay, so hello everyone. My name is Ibrahim Hanbal. I am a teacher handling the 3I subject, and in this video, I'll be going over UML diagrams, specifically the class diagram. So the class diagram is a diagram meant to showcase the classes in your system as well as the relationship between those classes. And to do that, it makes use of this box over here, which is divided into three parts: the class name, the attributes and behavior. This is meant to represent the different classes that exist in your system. So for each class, you will have one of these boxes. So let's go over the parts of the class that are listed here. We have the class name, obviously the name of the class itself. This can be, let's say, the name itself or the file name. So for example, student or student.java if you're using Java classes. For the attributes, these are the characteristics or the variables that are involved in your system. So, for example, for students, some of the characteristics or the ways that we can describe the characteristics of the students are their name, their student ID, their address, strand, etc. On the other hand, let's say we have a teacher. For the teacher, we can describe them with their name, teacher ID, their department, position, and so on. So those are the attributes. These are the different variables that exist in your class. Next up is the behavior. These are the different actions or the different methods that your class has. So, for example, confirm attendance, download activity, submit activity. In other words, those are the specific actions that your class can perform. So, if let's say it's a teacher, they'll be able to upload activity, check grades, or upload grades, and so on, as an example. Okay? Now, how do we write down the attributes and behavior? So attributes, as you can see here in the example, the attributes is written like so. You start off with what we call the visibility. I'll discuss that in a moment. Visibility followed by the name of the attribute or the variable name, followed by a colon, and then lastly the data type, so string. So for example, let's say you will place the strand as a attribute, you'd place colon, and then for the strand, I want it to be a text, so it will be in the form of a string. That is for the attributes. For the behaviors, we'll write it in a similar fashion. We start off with the visibility, followed by the name of the attribute or the name of the action. So for example, let's say here we have submit activity, and then open close parentheses. So this can be different actions or different methods. Let's say for teacher, they can upload grade, and that will be one of their behaviors. Okay, now let us go over the first part here, the visibility. You'll notice that for the attributes, they're all dash or minuses. For the behaviors, they are all plus symbols. Now, what are these? We have four specific visibility. So this is called the visibility icons, and we have four. We have the dash, we have the plus symbol, we have the hash symbol, and we have the tilde symbol. So what are these? These determine whether the attribute or behavior is private in terms of the dash, public for the plus, protected for the hash, and package for the tilde symbol. In other words, for this attribute here, this means that this variable name is a private variable. And for this method here, confirm attendance, this says that this method is public. So that's the meaning of those visibility icons or those visibility symbols. Again, dash is private, plus is public, hash is protected, and tilde is package. So just a note for all of you creating your class diagrams. To simplify the process, kindly make use of just these two. So for the dash, you can make that, or that can be all for your attributes, and the plus can be more for your methods or your behavior. So this is to simplify the process of creating your classes. I would like you all to focus more on creating your attributes themselves and the behaviors instead of trying to worry about whether to make this public or private. Generally speaking, all most of your attributes will be private and most of your behavior should be public. Although there are cases when you might want a variable to be public or protected depending on what type of system you're making, but generally speaking, you can just follow this format. Uh, Minus or uh, private for variables or attributes and public for behaviors or methods. Okay, so let me leave that there for now. Okay, now let us look at now the relationships that our various classes can have. We have four here: association, aggregation, composition, generalization. Let's start with the first one, association. So this represents a common or a sort of equal relationship between two classes. In other words, we have the class 1, class 2. These have equal standing in our system. So in this case, the student will submit the activity to the teacher. Pretty straightforward. Um, this indicates that the student will be submitting based on the description here. So take note, this will be determined by you. So you can place here, let's say, manages, or you can place here manages, or you can place here submits, or you can place here, enrolls, depending on what type of system you have. Yes, so you that is what you'll place for the association. These symbols here, this is multiplicity. I'll explain this a bit later, but to uh, to explain how it's used in this context, one teacher here will manage or will receive activities from many students, or many students here will submit activities to one teacher. Okay, so that's the association relationship. Again, we simply have a straightforward relationship between two classes. Next up is the aggregation relationship, which is sort of a whole and its parts relationship. In other words, we have the whole and then the parts. So, what does this mean? Taking this example here, a school is composed of or has classrooms. So, obviously, the school represents the whole, and then the parts is represented by, or one of the parts is represented by the classroom. So to draw the aggregation relationship, we make use of a straight line followed by a diamond. So whichever class the diamond points to will be the parent class, and whichever class is pointing away from the diamond, so here is the child class. So this indicates that the classroom is the child class, which composes the school, which is the parent class. And as seen here, one school is composed of many classrooms. So what does this tell us? The aggregation means that the whole or the parts cannot exist without the whole. In other words, if you remove the school class, the classroom cannot stand on its own. That's the idea here. So the child class is dependent on the parent class for aggregation. The opposite of that is composition. So as you can see here, the composition is represented by a line followed by a shaded diamond. So the shaded diamond is the parent class and the opposite end is the child class. So composition represents a has a relationship. It's similar to aggregation, but the child class is not dependent on the parent class. In other words, in this situation, the student can exist without the student org. So another way to think about this is that students are not required to join a student org. It's optional. So either they can be part of a student org or they can not join any student orgs. So that is what the composition relationship represents. So as you can see here, if we were to remove the student org, the student class can stand on its own. Okay, so as seen here, one student org can have many students as its members. The opposite of that again is the aggregation, where the child class, the classroom, cannot stand on its own if it's separated from the parent class. The fourth relationship is generalization. So here, student, or we have what we call uh, inheritance. So another term for this is inheritance. So in this case, the student is the parent or the superclass, and then student assistant, and irregular student are both subclasses or child classes. So what this means is that the student assistant class and the regular student class will inherit the attributes and the behaviors of the parent class. So this will have the same attributes as the student, the same behavior, same with this, but student assistant and a regular student will have their own unique attributes or unique behaviors. So the way we demonstrate this is by drawing an arrow pointing from the child to the parent class. So in this case, wherever the arrow's pointing is the parent or the superclass, and then wherever the arrow's pointing away from is the child class or the subclass. Okay, in this case, we don't really need to use the multiplicity, in other words, the number or the asterisk here. Okay. Lastly, multiplicity. So you've probably seen that already. Multiplicity is to determine or to quote an exact amount of figures. So in other words, if you want to denote 1 is to 1, 1 is to many is to many, and so on, we make use of multiplicity symbols for that. So here are the different symbols that you can use. It can be constant, it can be 0 is to many, 1 is to many, range, and so on. So in this case, let's say for this example, we have 1 is to many, 1 is to many, 1 is to many, and so on. If you want to have 1 is to 1, you simply write 1 and 1. If you want to have a range, you can have, let's say, 5 is to 10 or 10 is to 20, and so on. That is for the multiplicity symbols. Okay? So that is for the parts of the class diagram. Now let's put it into practice. So let's open up another file here. So let us think of a situation. Let's say we want to make a class diagram for a uh, online module system. So class diagram for an online module system. Let's say that this is our hypothetical system. Let's put that there. So I've already placed a class here. Oops. So let us draw some additional classes in order to fill up our class diagram. So let's have maybe 3 more classes. So let's put that here. Let's draw another class here. Let's draw a line, enter, and here. Then we can just copy this, there, and okay. And then let's have one more. I'll draw another one, but this time I'll make it a bit smaller. And let's add the dividers. So here and here. So I'll explain why it looks like this in a moment. Or I'll explain why there is basically no space for the behaviors in a moment. Okay, so let's have the class diagram for an online module system. So let's define the classes. What classes should compose this system? So let's start with the basics. Obviously, we can have a student. So let's have a student here. There we go. Then let's have maybe a teacher. So a teacher. And then let's have a course. And then for the last one, let's have a strand. There we go. So how does this work? Or how will this setup work? So let us first define rather the different attributes and different activities that all of our classes can do. So let's start with student. Student obviously will define their attributes. Let's just reduce the font size of this. Let's say the student obviously has a name. That will be a string. They have a student ID. That will be an integer. Let's decrease the font size. There we go. We also have a address followed by a string, and we have a track. So if you're a part of STEM or ICT or ABM and so on. And then for the actions, since this is an online module system, obviously the student can view activity. Activity. They can also submit activity. Okay, and they can also download modules. There. Okay, so this is now our student class. So we have 4 attributes and different um, three different uh, behaviors. Let's add one more. They can comment there. So if you want to comment, they want to give a suggestion, they can do that as well. Let's go now to the um, teacher. So in the teacher class, we have, let's have 4 attributes again. So we have name, string, we have the teacher ID in the form of an integer. We will have their address, obviously. Oops, address, string, and let's have their department as another attribute. Department string. Okay, great. What about now the behaviors? What can the teacher do as a class, or what can they do in the system? Well, they can upload modules, they can, uh, let's say, update grades, and they can assign activities. So assign activity. Take note that when writing the behaviors, you can actually specify specific variables in your action. So for example, update grades, I can specify that the grade will have, or this action or this behavior or this method will have a specific variable integer grade. So this will specify that this update grades must have an input of a number, which is the grade. Okay? Let's go now to the course. What are some attributes for the course? We have obviously the name of the course. We have the uh, course description. Oops, we have the course description in the form of a string. And then we have obviously the course code, which is also a string. Okay. And for the actions that are involved here, the course class can add a course or they can remove a course. So quite straightforward. And then lastly, for the strand is a bit special in this case because we will only give it attributes. So we have the name, we have the uh, strand description, which is a string, and we have the strand code, you could say, which is also a string. Now, in this case, the strand will not have any behaviors. Why? Because it is simply, this class is simply used to help us classify or used to help us organize the courses. So obviously, in ICT, the strand ICT, they have their own set of courses. CCS has their own set of courses. Or ICT ANI and CCS have their own set of courses rather. STEM, ABM, and so on have their own courses. So that is what this class is for. That's why we'll not give it any behaviors. It's not meant to do anything. It's just meant to help us organize the different courses into strands. So let us draw now the relationship. So again, let us have association for these three, and then let's draw, let's see, we can have a composition for the course or for the strand and the course. So let's start first with the student and the course. So we'll draw a straight line. Then let's draw another one here. There we go. And then here. And then there we go. Okay, so this is now our association relationship between the student, teacher, and course. And then let us draw one more line here for the course and the strand. Okay, great. Now, as I mentioned earlier, we will have a composition relationship. So let us draw, or not composition, let's do aggregation. Aggregation relationship. Oops, that's the wrong symbol and the wrong shape style. There we go. Okay, before we get into filling up the relationships between these, why did I use a aggregation symbol? Because in this case, the course or the strand is composed of courses, and you can't really have a course without a strand. All courses that are usually offered in a school, whether that's senior high or college and so on, they are listed under a specific strand or specific degree. So that is why we use the composition relationship. We cannot just have a course sit on its own there in the corner. So that is the reason for that. As for this, generally speaking, these are equal in relationship, so we will have the association for all three classes. So let us first specify what is the association relationship. So let's say for student, what is the relationship to a course? They are enrolled. So the student is enrolled in A. So it's like creating a sentence or a phrase. The student is enrolled in a course. Let's make that a bit bigger. There we go. What about the student and the teacher? So the student is submits activities to. So the student submits activities to the teacher. There we go. So that is now our relationship between the student and the teacher. And lastly, teacher and the course. So what will the relationship be here? The teacher handles a course. There we go. So pretty straightforward. This should be good so far, but we're missing one more thing, and that is the course here. So how is the course part of the strand? A course is a part of there. So those are now our four relationships. Let us now include the multiplicity symbol so that we know how many are linked to each other. So in the case of the student, we have one student and multiple courses because obviously you can be enrolled in many subjects. Same thing with the students. Many students are going to submit their activities to one teacher. And we also have one teacher who will handle many courses. And then lastly, many courses are composed or are categorized into one strand. So ICT again has many courses, ICT ANI has many courses, ICT CCS has many courses, and so on. So that's pretty much now our class diagram, as you can see. So this is a simple class diagram for our online module system. Again, this has been simplified for the sake of explaining how to create your own class diagram. So again, I hope that this has been informative and thank you very much for watching. Okay.